Is that for all types of sources? Yes, the principle of electrons generally not entering and exiting ideally functioning sources still applies to most other types of sources like batteries. While there are some complexities and exceptions, for most common power sources, the same reasoning holds. Reasoning behind electron flow. Sources generally create a potential difference. They establish a voltage that pushes electrons through an external circuit similar to a pump pushing water through a pipe. Electrons flow in the external circuit. This flow establishes an electric field that exerts the force on electrons. Electrons move from areas of lower potential, negative terminal, to areas of higher potential, positive terminal. Internal processes may differ. Sources like solar panels use light to excite electrons, generators use magnetic fields, and power supplies use various electronic circuits. However, regardless of internal mechanism, they all establish a voltage that drives electron flow in the external circuit. Examples of other common sources and their electron flow. Solar panels. Electrons excited by light flow through the panel itself, creating a voltage applied to the external circuit. Electrons do not jump in and out of the panel. Generators. Rotating magnets induce a voltage in the generator's coils, pushing electrons through the external circuit. Electrons remain within the conductor wires connected to the generator. Power supplies. They convert AC or DC from the grid into the different voltages using transformers and electronic circuits. The electrons flow within the internal circuitry and the connected external load, not leaving or entering the power supply itself. Exceptions and complexities. Leakage currents. In real world scenarios, slight imperfections in insulation or component behavior can lead to minimal leakage. Currents where small numbers of electrons might stray outside their ideal paths. However, these are generally negligible compared to the main current flow. Specialized components. Some specialized components like electron emitters or pumps are designed to actively inject or extract electrons. However, there are some not considered standard power sources. In conclusion, understanding electron flow within sources and electrical circuits is crucial in electronics. While specific internal mechanisms of sources differ, the fundamental principle of electrons not entering and exiting ideal sources remain relevant for most common power sources, focusing the flow through the external circuit. Remember that this explanation serves as a simplified model and real-world situations might involve minor complexities.